welcome the new episode of JEE Sprint 2.0 and you are watching Vedantu. I am your master teacher physics, Mohammed Shadab. I have a long teaching experience of 13 years and I taught at Mental more than 30,000 students and produced more than 1,000 ranks for JEE. Right? And thank you very much for your love and support. And I am getting so much messages from all of you guys on many social medias like Instagram, Facebook and all this. And I am also replying and trying to reply all of you. But due to some busy schedule, a little bit busy schedule, I am not able to make for all of you. But definitely I will for all of you. Yeah. Okay. So let's start the today's session, that is JEE Sprint 2.0. Right? And now I took a topic which is a little bit ignored one, जिसको हम थोड़ा सा ignore कर देते हैं, but they are scoring and they are very easy. And by these chapter we can easily score the marks in JEE Mains examination. Okay, guys? So very important topic, but very easy, but a little bit ignored. And these topics are, you can see here, that is thermal expansion and elasticity and the calorimetry. बहुत छोटे छोटे क्वेश्चंस होते हैं, बहुत छोटी सी कैलकुलेशन होती है और आपको बहुत ज्यादा इसमें मेहनत करने की जरूरत नहीं होती है, बट इफ यू हैव द बेसिक आइडिया देन यू कैन इजीली स्कोर. सो गाइस, लेट्स स्टार्ट. ओके, नाउ the first question is a very easy one. You have, see here, a pendulum made of a uniform wire. And you know already what is actually the formula for the time period. So the formula for the time period is T is equal to 2 pi under root L by G. So let's say, what's change here? Pendulum made of uniform wire, point to be noted, of cross-sectional area A has a time period T. When additional mass M is added to that bob, the time period will change. And before the time period was T, now the time period is Tm. So let's see what's the formula actually. We have the formula T is equal to 2 pi under root L divided by G. By addition of some mass, what will happen? There is a change in length. The length will increase. If the length will increase, it means the time period also increase. So now let the change in length is delta L here. ये बात समझ पा रहे हो ना? बहुत ही आसान सा. अगर उसमें मास लटका दिया गया तो क्या होगा? लेंथ इंक्रीज होगी. क्यों इंक्रीज होगी उसकी भी बात करते हैं, बट उस लेंथ के इंक्रीज होने से होगा क्या? नाउ द टाइम पीरियड विल बी Tm, right? And you get 2 pi under root of L plus delta L divided by G. Got it, my dear students? Very good. शाबाश. चलो अब इसके बाद देखते हैं यार क्या होगा. Okay. Delta L क्यों इंक्रीज हुआ होगा? So for this we have elasticity formula F upon A is equal to young modulus of elasticity into delta L divided by original length. Got it? So what's F here? F is the mass into G, mg force अपने अप्लाई किया, and cross section area is A is equal to Y and delta L divided by L. Got it? So what should be the value of delta L here? So delta L we can see here mg into L divided by A. Okay? So mass के वहां से hang करने से, load करने से, there is a change or the increment in that length is delta L, and that delta L is this. So if we put that L here, so the Tm that you have, Tm is equal to, that is 2 pi, okay, under root of L. When we put here L, so L will be common, we can say L1 plus, and this is mg divided by Ay and divided by G. I think you are getting all this thing. Now, if we divide this and this, then what will we get? If we divide it, Tm, then we'll get here Tm upon T is equal to 2 pi will be cancelled out, root L, root G will be cancelled out, and we get only root of 1 plus mg divided by ay. Now we can say Tm upon T whole square, right? Removing the root, it will be a square here, then minus 1 here, and here we get is equal to mg divided by ay. So what we have to find here, ध्यान से देखिए क्या निकालना था हमको. See here we have to find 1 upon y. 1 upon y is modulus of the material of the wire is y, then 1 upon y is equal to where g is the gravitational acceleration. So easily we can see 1 upon y is equal to a divided by mg of this. अब ये option हमको कहीं दिख रहा है dear? Yes, here is the answer D, right? So इसमें SHM एंड इलास्टिसिटी का कॉम्बिनेशन था. बहुत ही आसान सा क्वेश्चन था. अगर आप इन क्वेश्चंस पे ध्यान दे लेते हैं, छोटे छोटे चैप्टर्स जिनको आप इग्नोर कर देते हैं, जो या लास्ट में पढ़ाए जाते हैं या आपको नहीं पढ़ाए जाते हैं, लेकिन उनसे स्कोरिंग करना बहुत बहुत आसान होता है. दीज आर वेरी इजी. सो दैट वी विल कंटिन्यू टू दिस टाइप ऑफ क्वेश्चन एंड स्कोर हाई, राइट? सो अगेन the next question is, you can see here, also a very easy question and same type of question here. This very good and very scoring. See here. Now, pressure of a medium. See, pressure of a medium changed from this to this. So what will happen? We have change in pressure, that is dP, or you can say delta P, that is the change in pressure, and this minus this minus this, then what we get? 1.165 and 1.01. Okay, so we can subtract 1.165 and 1.010. Then what we get? We get 5 here, we get again 5 here, then 1.0. So what's the value of this? The value of this is 0.155 into 10 to the power 5 as given here, that is in Pascal, right? So what will happen when we change the pressure? Due to the change in pressure, there is a change in volume, and change in volume is given as 10%. Are you aware of change in volume? Also known as the volumetric strain, and this is given as volumetric strain dV upon. Here we increasing the pressure. See, we increasing the pressure or decreasing? Yes, we increasing the pressure. So when we increase the pressure, the volume will decrease. So volumetric strain is this. Change in volume in percent multiplied by 100, that is given as 10. So here we can say minus dV upon V is equal to 0.1. Okay, very easy calculation. Now what we have to find? We have to find the bulk modulus of the medium. So what's the formula for the bulk modulus here? For bulk modulus, you already know the formula. B is equal to change in pressure divided by mod of dV upon V. Yeah, what is this? This is change in volume. Why the volume changes? अगर हम pressure increase करेंगे तो volume compress होगा. Change in volume upon original volume is known as, yes, volumetric strain. Now we have all this. So bulk modulus of elasticity dP, that is 0.155 into 10 to the power 5, and here we get 0.1. So what should be the answer? 0.1 here, 0.1 here. So we can say the answer is 1.55 into 10 to the power 5 Pascal. Got it? So this is the bulk modulus of elasticity. Unit is Pascal because this one is unitless. volume upon volume, ratio of the same quantity. That's why it is unitless. And if it is unitless, then it has no unit and the unit of B is same as P. Got it? Another very easy question, bulk modulus पे question आ सकता है. Bulk modulus क्या है? आप ये formula देखें, B is equal to change in pressure divided by volumetric strain. Okay guys, so let's move ahead. So remove this for the next question. Next question is also a very good question. Graph. Okay, but it's very easy. Graph देखिए, maybe you scared of this, the question and option. Let's see, what is this? The adjacent graph shows the extension delta L. What is here? Delta L of wire of length, original length 1 meter is given here, from the top of a roof at the end with a load W, right, connected to the other end. If the cross-sectional area A आ गया, got it? Now you have to find what? Young's modulus of material. So what we have to do? We have to do just a very simple calculation. So let's see. We have the formula for this. Stress is equal to Y and Y into strain. You can see here. Stress is what? Stress is load divided by cross-sectional area is equal to Y, and this is delta L upon actual. And what we have here? We have a graph between delta L and W, and the equation is like a straight line. So for a straight line, we can see the equation is Y is equal to mx, and it seems to be passed through the origin. So the equation should be like Y is equal to mx. And here, what is Y? What is Y? Y is here delta L is equal to something constant, and that constant is actually known as the slope. And x, what is x here? X is W here. Got it? चलो देखो, अब यहां से आगे क्या है? Delta L is equal to something into W. This is the equation. Okay? So यहां पर भी हमको इसी फॉर्म में लाना है. Delta is equal to something into W. So we can write delta L is equal to W into L divided by A into Y. Right? And better way we can write what? L upon AY and W. So this is that constant. And what is that constant? That constant is actually the slope of the line. So what is the slope here, dear? Slope we can see, once again, slope we can see this, and here this angle is supposed to be theta. So what we can write? What is the slope? Slope is equal to, dear, tan theta. And what is tan theta? Slope is equal to tan theta. And what is tan theta? Tan theta is perpendicular upon base. So from this triangle we can say perpendicular and base. So the perpendicular is 1 to 4, that is 3 into 10 to the power minus 4. Right? And here this line is the base 80 and this 20, so we can say here 20. So what should be the slope? Slope is tan theta, right? And tan theta is perpendicular upon base. So perpendicular upon base, perpendicular is 3 into 10 to the power minus 4, and base is equal to 60. So slope is equal to 10 to the power minus 10 to the power minus 4 divided by 20. Now we have the slope, and from another equation we have the slope like this. So L upon A Y should be equal to 10 to the power minus 4 upon 20. right? So what we have to find? We have to find the modulus, means we have to find y. So y can be written as L into 20. Y L into 20 divided by A into 10 to the power minus 4. Now we can write y is equal to L. What is L here? L is given here something 1 meter, right? So this is 1 into 20 divided by A. A is 10 to the power minus 6 into 10 to the power minus 4. So what should be the answer? We have minus 10, 20 into 10 to the power minus 10, ऊपर जाके plus 10. So this is 2 into 10 to the power 11. So where is the answer? There, here is the answer. That is 2 into 10 to the power 11. Okay guys? तो यहां तक हम देख रहे हैं बहुत ही आसान है, थोड़ा सा कैलकुलेशन है, कंसेप्चुअली दिस इज वेरी इजी और इन क्वेश्चंस की प्रैक्टिस करके हम लोग बहुत अच्छा स्कोर कर सकते हैं. सो व्हाट यू हैव टू डू, जस्ट गो थ्रू द चैप्टर इन योर बुक्स एंड फाइंड सम वेरी गुड क्वेश्चंस, सम एग्जांपल, मे बी सम सॉल्व एग्जांपल, and then solve them by yourself on your copy and pen. Then when you solve nearly 40-50 question of this type and of this chapter, then definitely you can increase your score by 5 to 10% in JEE Main. Definitely remember this, ध्यान रखना इस बात को, क्योंकि छोटे हैं, स्कोरिंग है, गलती होने के चांसेस नहीं है और बहुत ही आसानी से इंसान समझ जाते हैं. Okay, so let's move. Let's see what's the next here. So another question here, also a very good question. Given quantity of an ideal gas, pressure P, absolute temperature T, isothermal bulk modulus. Isothermal means temperature constant. Temperature constant means what we can do? We can PV is equal to constant. If we can say PV is equal to constant K, what we have to find here? Just we have to find here bulk modulus. Bulk modulus क्या है? फॉर्मूला भी हम लोग ने पहले देखा था. क्या फॉर्मूला देखा था? bulk modulus का फॉर्मूला क्या था अपने पास? bulk modulus B is equal to dP divided by mod of dV upon V. Okay, so just we have to find this. So how we can find? Just differentiate it. P into dV plus V into dP is equal to 0. Here we can say P dV is equal to minus V dP. Okay guys, if we have minus V dP, so we can say what? P is equal to minus V dP divided by dV, and here we can say P is equal to dP divided by minus dV upon V. Okay, and we just have to find this one, and this value is equal to P. So the bulk modulus of isothermal is nothing but P. A very easy question. One more topic is there. If it says find the adiabatic, अगर आपसे ये adiabatic bulk modulus पूछा जाता तो इसी तरह से हम लोग करते, बट PV की जगह क्या लेते? PV is equal to gamma constant, और फिर जो आंसर होता that is bulk modulus for this is gamma P. Right? So it's not the case, but for here we can say PV is equal to K isothermal. For isothermal the bulk modulus is P. Another very easy question here. Okay, let's move ahead. देखते हैं और क्या है खजाने में. चलिए आगे देखें अगले क्वेश्चन के लिए. So the next question is also a similar type of question but also very easy. See here what the question is. Question is two rods, different materials, means y1 and y2. अलग अलग होगा. अरे बोलो भाई, Yes, because Y is the young modulus of elasticity, and young modulus of elasticity is the property of material. And if the two different material means it has different Y means Y1 and Y2, and they are here. Thermal expansion, alpha 1 and alpha 2, coefficient of thermal expansion. So the coefficient of thermal expansion is given as alpha 1 and alpha 2, and that alpha 1 and alpha 2 are given here. Young modulus is Y1, Y2 respectively are fixed between two rigid massive walls. Two massive walls in between, they are fixed, means they are not allowed to expand. If they are not allowed to expand, then due to the required expansion, there must be a thermal stress. That stress will be developed because the required extension is not allowed to do. Due to this, we have to find that thermal stress. What is the thermal stress? Let's see. If there is a change in delta L, then what is the stress? The stress developed is F upon A is equal to young modulus divided by delta L into L. But this delta L by L is change in length upon original length, that is known as strain. And why this strain will produce? Due to change in temperature. Because the change in temperature is, see here, rods are heated such that they undergo same increase in temperature. Same increase in temperature, that is delta theta. And if delta theta is there, they must increase their length. And what is the increment in length? L dash is equal to L naught 1 plus alpha delta theta. Now when we multiply, we get L dash is equal to L naught plus L naught alpha delta theta. Right? Now we can say L dash minus L naught upon L naught is equal to alpha delta theta. Got it? And what is that L dash minus L naught? L dash final length, L naught initial length. So L dash minus L naught is actually change in length divided by original length is equal to alpha delta theta. This is the required strain. If this is the strain, then the stress is F upon A is Y into alpha delta theta. Okay? And see here, there is no bending. Alpha 1 into alpha 2 ratio of thermal expansion is 2 into 3. The thermal stresses developed in rods are equal. Right? Equal. Thermal stresses are equal. Means this is equal for these two. Now, for first one, thermal stress is Y1, alpha 1, delta theta. For second one, it is Y2, alpha 2 into delta theta. According to the question, delta theta same and thermal stresses are same, then we should have Y1 alpha 1 is equal to Y2 alpha 2. And now we have to find Y1 ratio Y2. What we have to find? Y1 ratio Y2. So Y1 ratio Y2 is equal to alpha 2 upon alpha 1. Okay? So Y1 ratio Y2 alpha 2 upon means reverse of the ratio. If alpha 1 ratio alpha 2 is given as 2 by 3, so Y1 Y2 is reverse of this, means 3 by 2. So the answer is, my dear students, 3 by 2. Okay? Are you getting my point? Are you getting me? Are you getting my explanation? Yes, very good. So the answer for this is 3 by 2. Another very easy and scoring question. मतलब फ्री का लल्लू सा क्वेश्चन. आपको कुछ नहीं करना है, जस्ट थोड़ी सी कैलकुलेशन. या इसमें वो IIT जैसे क्वेश्चन वाली बात नहीं जो मैकेनिक्स में और दूसरे टॉपिक में बहुत ज्यादा हमें सोचना पड़ता है. यहाँ पर सीधा सा रास्ता है, जस्ट आपको मूव करते जाना है. ओके, चलिए लेट्स मूव फॉर द नेक्स्ट वन. This is a very easy question. Now the next question that we have to tackle is also a same level type. See, following 4 wires. There are 4 wires, dear students. Made of, these are the following 4 wires. Same material means why same. Those will have the largest extension when same tension. T is also same. So just we make the formula in this. If we make the formula for extension, we have same tension is applied. So T upon area of cross section A, this is the stress, is equal to Y, change in length delta L upon original length. Original length is there and diameter is here. Okay. Now the change in length delta L can be written as T into L, right, divided by A into Y. And following 4 wires are made of same material, means Y is same. Have largest extension when same tension is also same. So delta L is proportional to their L upon A, and you can say L upon pi r square, because radius diameter is given as. So if the diameter is given, then what we can say? We can say L divided by pi d square by 4. Pi by 4 is also same, so we have to just check L upon d square. L upon d square is directly proportional to delta L. Yani कि चारों ऑप्शन में we have to put the value, or by the common sense we just find L upon d square. L upon d square is maximum for which wire? For A. If you calculate, then it will become like A. For A, L is 50, diameter is this. इसके लिए maximum होगा, और इसी maximum extension को पूछा गया है. Then definitely this is your answer. Do calculate. Okay, I am not doing the calculation here, just leaving for you people, and you are intelligent enough, then you can do very easily. So this is the answer A. Right? So let's move for the next one. Okay? Now, another question, also an easy one. When a certain weight suspended from, certain weight suspended from a long wire, let the weight is W, its length increases by 1 centimeter. What is 1 centimeter? That is delta L. If the same weight is suspended from another wire of same material, means दोनों के लिए y कैसा होगा? Same होगा. And length, but having a diameter half of the first one, the increase in length will be. So again we have to find what? Increase in length. So increase in length के लिए we have the formula W, same weight upon area is equal to Y into delta L upon L. So that increase in length delta L is equal to L into W upon A into Y. Got it? Now W same. Okay? From another wire of same material and length, means same material Y same, same length L same. So we can say delta L is inversely proportional to area of cross section. Okay? Now see here. Now first length increased by 1 centimeter. If the same weight suspended from another wire, same material, but having diameter half diameter, then cross section area. What about the cross section area if the diameter will be half? Yes, 1 by 4. Okay, so A dash is equal to A by 4. So delta L dash becomes becomes 4 times of delta L. So delta L is in previous case that is 1 centimeter. So for another case this is 4 times of this, and this is your answer, 4 times of 1 centimeter. Then the net increment in the second wire is 4 centimeter. Got it? Yes. Another very easy question, right? Okay. चलिए next move करते हैं. Next one, another similar type of question also. The ratio of diameters of two wires of same material. Same material means Y is same. Diameter ratio is n:1. Length of each wire length same. On applying the same load, increasing length of thin wire will be, right? Same question है, इसीलिए जानबूझ के हमने आपको रखा. बिल्कुल वैसी कैलकुलेशन होगी, बिल्कुल वैसी होगी, और फिर आपको रिजल्ट मिलेगा डेल्टा L प्रोपोर्शनल टू 1/A. ओके, एंड is n:1, so this is 1:n square. So what should be the increment in length, increase in length of thin wire will be n square times. Similar calculation. Okay, so this is another one very easy type of question. Okay dear students, चलिए फिर आगे चलते हैं. Yes, another is also a little bit tricky question. Let's see what is this. Mild steel wire of length 2L and cross sectional area A is stretched well within elastic limit. Means stress is directly proportional to strain. That is the elastic limit is stretched within the elastic limit horizontally between two plugs as shown in figure. Mass M is suspended from the midpoint. Strain. So dear, what is the strain actually? Strain is, yes, delta L upon L, that we have to find here. And now when we draw a triangle like this, then we can see this length is L and this length is X. So what about L dash? L dash, you can say L dash is equal to root of L square plus X square. Got it? So what is the change in length? Change in length, my dear students, L dash minus L. L dash is this length. Okay, and L is this length. The change in length is difference of this. So what's the L dash? We can put L dash here, root of L square plus X square minus L. Now if we take L common, so L root of 1 plus X square upon L square minus L. So when we take L common, here we have 1 plus X square by L square, 1 by 2 minus 1. Got it? Then we use here binomial approximation. Why? Because you know that when we put a mass here or suspended a mass here, X is very small as compared to L. If X is very small extension here there, then X upon L and X square upon L square is also very small. And if this is X square upon L square very small, then 1 plus X to the power N can be written as 1 plus NX. So by using the binomial approximation, I can say delta L is equal to L1 plus X square divided by 2L square minus 1. 1 will be cancelled out. So we have delta L upon L is equal to X square upon 2L square, and this is your answer. Where is it? X square upon 2L square. Here it is. So the answer for this question, the strain developed in it, X square upon 2L. So गलती आप क्या करेंगे? Most of the students will try to solve that strain is equal to F upon A into Y delta L upon L. So इसके लिए F उनको यहाँ से T की वैल्यू निकाल के F upon A Y डेल्टा एल अपॉन एल करेंगे, बट यहां ऐसा नहीं करना है. स्ट्रेन जस्ट डेल्टा एल अपॉन एल. गॉट इट? डायमेंशनली भी आप इसको नहीं कर सकते हैं क्योंकि दो ऑप्शन एक जैसे आ जाएंगे. स्ट्रेन इज डायमेंशनलेस, दिस आल्सो इज डायमेंशनलेस, दिस इज आल्सो डायमेंशनलेस. सो यू हैव टू डू और प्रोसीड लाइक दिस. Okay, so let's see for the next one. This is also one easy question. Another, you have also a very easy question. Uniform wire fixed at its upper end, hangs vertically and supports a weight its lower end. Its radius is r, length is l. Young's modulus for the material of the wire is E. The extension is. So we have done it earlier. Very easy question because we have to find mass m, weight mg, force, cross section area A is equal to Young modulus, and Young modulus given here is y into delta L upon L. So change in length is equal to mg into L divided by AY. This is the change in length or increment length. Directly proportional to modulus of elasticity. So what's the modulus of elasticity? Here y is equal to E. It's not directly proportional. Inversely proportional to R. No. Square of the R here inversely proportional. Directly proportional to L. Yes, it is directly proportional to L. If it is directly proportional to L, so only third one is correct. So the answer is A. Only third one is correct. Got it? Very easy question, but the scoring one. Okay. Let's move for the next one also. See here, temperature of a wire of length 1 meter, area of cross section. This is area of cross section 1 centimeter square. Okay guys, increased from 0 to 100 degree centigrade. Increases from 0 to, again the thermal expansion, increment from 0 to 100 degree centigrade. If rod not allowed to increase in length, the force required will be. Okay, what we should do? We just find F upon A is equal to Young modulus into delta L upon L. So what is the strain which required to be? The strain is delta L upon L, and you know L dash is equal to L naught 1 plus alpha, and this is delta theta, change in length, as we do earlier. So earlier we also calculated. I am not doing to that much of calculation here. We already showed you that it will be like delta L upon L naught is equal to alpha delta theta. So F upon A is equal to y, and delta L upon L is alpha into delta theta. Okay dear students, so again a very easy question. Now just we have to put the values here. We have all the values. We have y. What's the y here dear? Yeah, given here y. So y is 10 to the power 11 dear. What about alpha? Alpha is given as 10 to the power minus 5. What about theta? Theta is given as 100, yani 10 to. Okay, now what is the answer? 10 to the power delta theta here, 10 to the power 2, 10 to the power 11, and here alpha 10 to the power minus 5. So yes, this is F upon A, 10 to the power 11, 10 to the power minus 5 into 10 to the power 2. So what we have to find? We have to find the force. So force is F upon A. So this is F. A is given here 1 centimeter square. That means 10 to the power minus 2 square. That's why it is minus 4 is equal to 10 to the power 11 plus 2 minus 5. Now force F is equal to 10 to the power 11 plus 2 minus 5 minus 4. Okay, so what we have, 10 to the power plus 13 minus 9 is equal to 10 to the power 4 Newton. So what should be the answer, dear? The answer is 10 to the power 4 Newton. Is a very easy question, but quite important as JEE Mains point of view, because these chapters are very easy, right? Okay, let's see for the next one here. Yeah, another a very good question, very easy question, and we can solve very easily. And this is substance breaks down by a stress 10 to the power 6. Okay, this is a breaking stress, means breaking stress means F upon A. If F upon A is 10 to the power 6, then the rod will break, means F upon A is equal to breaking stress, right? Then let's see what we have to do. If the density of the material is this, then the length of the wire of that substance which will break under its own weight, means F, from where F will be come, F is M into G, right? And this is the cross section area. Okay, so breaking strength F upon A is given as 10 to the power 6, M volume into density into G into A, right? So volume is length into cross sectional area into rho into G divided by A. A is the cross sectional area of the wire. Means the question asks, if we suspend here, then if this is the cross section area, then what is the maximum length? If length increases, then its mass or weight also increases. So the maximum tension will be here. What's the tension here? That tension is mg. And if that tension produces the stress equal to the breaking stress, then the rod or the wire will break. So what's the stress here? That stress here mg by A, and this should be limit for 10 to the power 6, and then we should put mg upon A, m volume into density, then volume is L into A will be cancelled out. So we have to find only L. So dear students, L is nothing but 10 to the power 6 divided by rho into G, and we have all the values. What? Because L is equal to 10 to the power 6. What about rho? Rho is given as density of the material 3 into 10 to the power 3, right? And G, that is 10. So what we have? 10 to the power 6 minus 4 divided by 3 means 100 by 3. So approximately, what is the answer? Approximately the answer is 34 meter, and here it is. Okay, so the answer is 34, means अगर हम 34 मीटर की लेंथ को लटका दें तो उसका वेट इतना हो जाएगा जिससे कि वो वायर यहां से, क्योंकि यही मैक्सिमम टेंशन होगी और यहां से ब्रेक हो जाएगा. Got it? Okay, let's move for the next question. That is from calorimetry, and it's a very important question. बहुत ध्यान से समझ के सोच के आप इसका जवाब दें. 10 gram of ice at 0 degree. Ice at 0 degree. So let's put here 10 gram ice, 0 degree centigrade. In a calorimeter of water equivalent 10 gram. So what is actually the water equivalent 10 gram? Means that calorimeter behaves same as the 10 gram of water will behave. Right? Means the calorimeter absorbs the amount of heat which is absorbed by the 10 gram of water at that particular range in temperature. Means the calorimeter behaves similarly as a 10 gram of water. This is the water equivalent. So 10 gram of water also. So we have 10 gram water and क्या है ये? Calorimeter, and the temperature is also 0 degree centigrade. Now what we have to find? We have to find how much heat should be supplied to the apparatus to evaporate the water thus formed. Means we have to evaporate that water. Then first this 10 gram should reach up to 100 gram of water, 100 degrees centigrade. So first it should be like 10 gram water at 0 degree centigrade. So which heat will involve here? Q is equal to ml. What's m here? 10 gram. L is 80. So we have 800 calorie of heat for this. Now we have 10 gram of water and again 10 gram of water of as a calorimeter at 0 degree. So actually we have 20 gram water at 0 degree centigrade. Now we have to convert it 20 gram water 100 degree centigrade. So for which formula should use? For this we have to use just Q is equal to ms delta theta. M is equal to 20, S is equal to 1, theta is equal to 100. So here we required 2000 calorie of heat here. 2000 here and 800 here. Now we have calorimeter, 10 gram water equivalent and 10 gram of water at 100 degrees centigrade. Now we have to evaporate the water. So only 10 gram of water will evaporate, not the calorimeter. So calorimeter remains as it is at 100 degrees centigrade and 10 gram of water will evaporate into steam. So there is a change in phase. So we required Q is equal to again ml, then Q, m is 10, L latent heat of steam. What is this? That is 540. Then here we get 5400 calorie of heat for this action. So what should be the total heat that we have? So the total heat that we have is Q is equal to 800 here, then 2000 here, then 5400. So the total heat required is 8200 of calorie. So what should be the answer? The answer that we have is question D and this is the answer. Okay, so this is also very easy question of calorimetry. तो calorimetry के इस क्वेश्चन को आप एक बार फिर से सॉल्व करेंगे और इस क्वेश्चन को सॉल्व करके इस तरह के और भी क्वेश्चन सॉल्व करेंगे क्योंकि बहुत छोटे छोटे चैप्टर्स हैं और इन चैप्टर्स से आप अच्छा स्कोर कर सकते हैं. Okay, so thank you guys for being with me. I am your master teacher of physics for IIT JEE, Mohammed Shadab, and thank you very much for your love and your support. And I am getting very messages from all of you, and all of you for supporting. Very thanks to you. Okay, so I am trying to reply each of you, but maybe some of you are left, but I will definitely reply. So keep sharing, keep watching, keep supporting and keep messaging on this for me, and all the best for your IIT JEE examination. Okay, all the best. So we will meet next in next episode, that is for thermodynamics, and which is also very important. We will next tomorrow again on the same channel, same place. जब तक के लिए सावधान रहें, सतर्क रहें और स्टडी करते रहें, प्रैक्टिस करते रहें, and be motivated for this. Okay, bye bye. Thank you.